Hello class, it's Mr. Ng, and here is giancoli, chapter 3, number 29. The question goes like this. Suppose the kick in example 3.5, and I have a little diagram here, was attempted 36 meters from the goalpost, whose crossbar is 3 meters above the ground. If the football is directed correctly between the goalposts, will it pass over the bar? Okay, so that means that this distance is now 36.0 meters, and they're wondering, so this is their little crossbar, this is supposed to be 3 meters tall, and then they're wondering if it can, make a field goal or whatever. And this thing, within that sample, the velocity here was 20, was 20, that's ugly, 20 meters per second that away with theta of 37. Okay, to set this up, we need to figure out x and y, right? So let's first do x. Oh, and the big secret here is you got to know that the velocity at the x is equal to the total velocity cosine theta, and then the velocity in the y, that's a y, is equal to big old velocity sine theta, right? Cosine theta x, sine theta y, right? Easy stuff. So let's consider the x values, right? Just going across. V, A, T, X, V initial, V final, acceleration, whatever. So the V initial is gonna equal to the big V, right? 20 cosine x. The V final is going to be the same thing, right? Because there's no acceleration. Acceleration is 0. Time, we don't really know. In fact, it would be nice to figure that out. How long is that ball in the air? But we do know this x, which is going to be 36.0 meters. So this becomes pretty easy. We can solve for time. Let's see, we know that velocity is equal to displacement divided by time. That means time is equal to displacement divided by velocity, right? So let's just fill that in. So that means it's going to equal to 36.0 meters divided by v cosine theta. V cosine theta, this is 20 cosine 37. When you plug this in, make sure that it's in degrees, not radians. A lot of kids got stuck for like 5 minutes. If you've been doing this problem for over 30 minutes and you're like, why can't I get the same answer as the book? Check your calculator and make sure it's in degrees. Radians are not, no radians. Degrees, yes. Okay. So what did we get when we do that? I got 15.97 meters per second, right? That's our Vx. So I'm going to divide, so this little v here is now 15.97 meters per second. Notice how meters cancel, seconds are going to go up there because it's divided and divided. So then I get my answer. That's the time is 2.25 seconds. This is useful. Let's use that in our y, all right? A little bit more math. So no longer thinking about it going left and right. Let's think about it going up and down. Namely, is it taller than 3 meters, right? Is it taller than 3 meters? So let's do our y math. V, A, T, X. V initial, V final, acceleration, time, and X. V initial here is going to be V sine theta, right? The big ol', the total V. The V final, we don't really know, right? And we don't really care. So I'm gonna draw a poopy. Right, that's a cyclops poopy, I guess. Acceleration is going to be negative 9.8 meters per second. The sign totally matters this time because we're going to need things to cancel out. The time we now know, haha, 2.25 seconds. And then the x, well, we don't really know, but we're hoping it to be more than 3 meters. So let's write out the equation. We know that x displacement is equal to x initial plus initial velocity times time plus 1/2 at squared. If you don't know where I got that, it's one of the classic equations that you just got to memorize. This is starting from the ground, so this cancels out, but we can totally fill out this other stuff. X is equal to v initial t plus 1/2 g, negative g, t squared. X is equal to v initial is equal to v sine theta. V sine theta is 20 sine 37. And when I plug that sucker in, I got 12.04 meters per second. So this is 12.04 meters per second times 2.25 seconds. Remember, we just found that out. Seconds will cancel. It's going to be in meters. That feels good. Plus 1/2 times negative 9.8 times 2.25 seconds squared. So when you plug in all that math, I got boom, 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 2.21. I got, let's see, I did all this and I got 27.08 meters minus, and then I did all this, and that was 24.81 meters. So if you did that math, this is the x is actually 2.21 meters, right? And it needed to be over 3, so no, not high enough. All right. So here, if you want to find the difference, 3 minus 2.21, let's see, 3 minus 2.21, it's like 7.79 meters too short, right? 0.79 meters short, not tall enough. I hope that works. I think I might have done this little math wrong because I'm looking at my notes, because sometimes I write things wrong. But you get it, right? Find the x. It didn't get over 3. Hope that helps, and thanks for watching. Thank you for working so hard. Keep working hard, guys. I love you guys.